I want to welcome you again, this time to our fourth, I believe, in the series of lectures on birds and flight and birds inside and out. Thanks everyone for being here. I know it's a little bit difficult to come in on a wonderful evening like this, isn't it? We should just assemble outside if we didn't need all the technology, but we'll benefit by that. So thanks for being here. As usual, I just need to ask you first to turn off your cell phones if you haven't done that yet, so that they won't interrupt us once we begin with the events of the evening. I'll also mention to you that I have the schedule, and you can get a copy of this out at the table in the front, a schedule for the MCT airings of this series. Looks as though the first one begins on March 30th, and the last one will happen on May the 8th, and there will be 4 airings of each lecture. So pick up a schedule for yourself. I'm sure you can also find it on the Alumni Association website. And it's always a lot of fun. I've said this before in this group, but I don't really have too much of a life, so occasionally on Saturday I'm just flicking my remote in the evening looking for something interesting. And then I run into one of my colleagues. It's really quite amazing. First, I'm surprised that I know somebody who's that famous. Then I'm surprised that I know somebody that smart, because it's wonderful to watch the lectures, even the second time around. So pay attention, because you'll be able to enjoy these lectures again. Also, I think we'll be selling some DVDs at the end, after the end of the series. So if you want to watch the whole series again, you'll be able to pick up a DVD, and it will be a lot of fun to revisit it. First, as usual, I'm going to be introducing our 2 poetry readers. We're going to have Eduardo Chirino, one of my colleagues from Modern and Classical Languages and Literatures. He's going to come and read his poem in Spanish. And then, as has been our custom, Jeff Badnock is going to come and give us an English translation, just for the few of us who really have sort of rocky Spanish. So, Eduardo, ready? Come on over.
Good evening. Tonight I will read a poem whose speaker is probably the most famous bird of our childhood, the roadrunner, or in Spanish, the correcaminos. Geocosic californianus, that's the Latin name of him. Sin duda me recuerdan, aunque debo decir que mi plumaje no es azul celeste, sino más bien castaño claro. Mis patas no son tan alargadas. Tampoco tengo ese penacho tan gracioso en la cabeza. ¿Qué le voy a hacer? Se trata de dibujos animados. Mi cola, eso sí, es bastante larga y sirve de timón cuando hago giros en mi alocada carrera. Alcanzo hasta 35 kilómetros por hora. Parece bastante para un pájaro tan pequeño y esmirriado, pero el coyote es más veloz y bastante más astuto. Cosas del equilibrio ecológico. Yo me alimento de culebras, insectos, lagartijas. El coyote se da un banquete con los míos. Mi única venganza son los dibujos animados. Ver al coyote rajado, herido, maltrecho y chamuscado. Gracias.
For the road runner. You'll remember me, no doubt, although I have to say my feathers are not sky blue, but more light brown. My legs are not so lengthy either, nor do I have that funny-looking tuft on my head. But what can I do? This is the stuff of cartoons. My tail is rather long, though, and acts as a sort of steering wheel when I turn in my crazed runs. I can reach speeds of up to 20 miles an hour. That seems fast enough for the small, skinny bird I am, but the coyote is swifter and more clever by far. A few bits about the food chain. I survive on snakes, insects, and lizards. The coyote feasts on my kind. My only revenge is in cartoons, seeing the coyote battered, crushed, injured, and singed.
Okay, so we find out that that the Roadrunner in the cartoons doesn't really look like the real Roadrunner. Don't bother us with that. Okay, my next task is to introduce our speaker for tonight, who is Professor Richard Hutto, who is a professor emeritus, but only recently emeritus of this university. And I was asking him a little bit earlier on how all of these wonderful bird people, birdmen and bird women, work together over there. It seems to me we had Phil Wright, whom I didn't know. We had Dick. We had many other people who are kind of younger and then older, and I wondered how they all work together, because in humanities we tend to be pretty solitary folks. We just sit at our desk and don't talk to anyone. And my sense of it is that it's a little bit different in the sciences, and I've always perceived that when I come to these lectures. And Dick did assure me that they all work together, and I suspect it's something of a little, not a dynasty, but dynasty of folks who keep coming here because they know of the work of people who have been here before them, and I think we can see a great advantage to that, and we're very fortunate to participate in that. Dick did tell me that he believes that the group of folks in wildlife biology who work on birds in one way or the next is one of the largest programs of that kind in the United States, maybe second to Cornell, and I don't know anything about Cornell, so they'll have to come another week and make their argument. But I've been really excited to hear all of these wonderful folks talk about birds inside and out. And Professor Hutto is going to talk to something which might have been in some of our minds this week as we've been enjoying this wonderful warm weather, quite uncharacteristic of March, and that is what's going to come along when fire season is here. And so Professor Hutto is going to be talking about birds and fires. His title is A Bird's Eye View of Severe Forest Fires. Welcome with me, Professor Richard Hutto.
Thank you. Thank you for sharing a nice evening. Coming out here instead of being outside hiking in the woods somewhere. What I want to do is talk about birds. Crow. Crowing. Chickadee, chickadee. I want to tell you that I think we have a lot to learn from birds if we just learn to listen. We have a lot to learn from birds if we just listen. And it's not the kind of listening we're going to do next week with Eric Green. He's going to help translate what in the world they're saying when they go tweet, tweet, and chack, chack, and whack, whack, and that kind of thing. I'm talking about a different kind of listening. I'm talking about listening to birds tell us what they like and don't like, where they like to be and where they don't like to be. Because if we just listen, we can learn a lot about land stewardship. So I'm going to start with a discussion of disturbance ecology. This is a big area in ecology. Oh yeah, turn the lights down, Eric's saying. Great, thanks. It'll be much better. Yeah, you don't need to see me. Okay. Disturbance ecology. This is an event that comes along, usually a physical event that kills large number of individuals. Okay, so it could be a windstorm, big blowdown, a hurricane, flood, fire, landslide, volcanic eruption, even a beetle outbreak, that kind of thing. And usually in ecology, we define a disturbance according to the fact that a lot of individuals are killed. But not all individuals. So there's an editing process, too. Some individuals may survive, and a lot of organic material may survive the event. And that's going to be really important because that's a legacy of the past environment that is carried on into the future forest. So what happens is, here's a forest. Let's see if I can get the sound to be more consistent. Here's a forest, the old growth, mature, something like that. An event comes along, like a fire, knocks it back to an earlier stage of development or succession, plant succession. This is a cool process in itself. It could take a whole lecture on why there's change in plants from one time to another. This thing's kind of on and off. Maybe I'll just do this. But what's really cool is different plants and animals occur at each of these stages of succession. So very different plants and animals at the early grass forb stage, then the shrub seedling stage, and then different ones in the pole sapling stage. And so if you like variety of life on Earth, you have to like disturbance because it gives rise to all these different kinds of plants and animals that proceed through time after the disturbance event. What's cool is in forested environments, we start the first stage with this sort of legacy of the past environment that was there. These dead trees, standing dead trees. That's going to be important for the story. But different critters occur in each of these stages of succession. Look out the window. You see Missoula. Look at the hillside. If I can find a laser, it doesn't matter. Up on the hill, you see forest and then no forest, forest, no forest. And why? Is it that the physical conditions here are very different than the conditions there? No, it's that a fire came in 1985, the Hellgate Canyon fire, burned it, knocked it back to an earlier stage of succession, so now we have a lot of variety in the kinds of things that we see. And Missoula is a cool place because of it. Look at it. Oh, wait, gee, what happened? I went the wrong way, that's what. Here, look at it 100 years ago. See how homogeneous the mountain was? What a boring place. Now Missoula is awesome. And the variety that we see out our window because of that wonderful event is right there staring us in the face. And so the diversity of life that we have right in the valley is in large part a result of that event that happened in 1985. And what Jim Habeck and Bob Mutch said back in the 70s is so cool. They said nearly all vegetation in the northern Rockies is at one stage or another of succession after a disturbance event. You're hard-pressed to find anything that you'd call an old-growth forest here. This is not the Pacific Northwest. Everything, pretty much, is at one stage or another of succession after disturbance. And so if we talk about fire, disturbance comes in different kinds of regimes or kind of averages of the way disturbance operates. It goes from high severity, infrequent events down to the bottom right, which is low severity, frequent events. Okay? And then in between, you have mixed severity fire regimes. And these different regimes occur in different environments, different kinds of forests, different kind of vegetation. The chaparral has a different regime from the eucalyptus forest in Australia, which has a different sort of fire regime from the fynbos in South Africa, for example. And so what's cool, in forested environments, the infrequent high severity regime is really typical of something like a boreal forest or subalpine forest. And the ponderosa pine, pure ponderosa, low elevation, dry ponderosa pine forest would be more typical of a frequent, low severity kind of regime. So the intensity or severity of a disturbance is usually inversely related to the frequency with which that disturbance happens. Now here's where a story begins. Pretty soon we'll get to birds. The low severity regime is thought to become altered since 1900. There's no more frequent low severity fire. So this environment that used to experience that kind of thing is now kind of becoming more like a high severity infrequent system. But the plants and animals that live here aren't adapted to that sort of thing, and so everyone's going, uh-oh, we're in trouble. We got a problem. We got to have a world out of whack. And how do we know this? Well, you ask the trees. They talk too, if we're willing to listen. So here's a tree that Steve Arno cut down, the bitterroot. It was, I like to say it was born, but it germinated here in 1612. There's the center of the tree. And then out here, oh, you see that little scar in 1659, 47 years later, it was this big around. And a fire came along. There was probably a bunch of needles piled up against it at the base, and got hurt. Ow. And so it started healing around that wound. And before it healed, you can see, doggone it, 1674, another fire came along. There's a bunch of sap there, and so, got hurt again. And it keeps getting re-injured and re-injured and re-injured in the same place. But what you can do is then count those events, and then you know how many fires the tree experienced through its lifetime. And here, this tree experiences fire every half a dozen to a dozen years. until 1915, way up on top, and then no more fire until it was cut down in 1974. And so there's a big gap there after about 1900. If you do this for lots of trees throughout the West, this is what you see. So here we can see, still trying to figure out if I can get the laser pointer. Oh, gee, that's not what I want. Some tell me glasses are pretty good. Okay, so we can go, from Arizona up the Rocky Mountains here in Colorado to Montana area, Eastern Oregon. Here's a bunch of different trees that have been lined up. Every line is a tree. Every red is when it got injured. And here's time at the bottom. So we have from year 2000 back to year 1000. And what you see, if you squint your eyes, is lots of fires, lots of fires, lots of fires until about this point right here. And then it kind of turns gray, doesn't it? 1900. The trees are saying, oh my gosh, nothing's burning anymore. And if you look at something like the Bitterroot, here's 1909 near Lake Como, wide open understory. In the 1920s, 30s, 40s, 50s, oh my God, there's more and more and more trees. There's fuel buildup. That's a consequence of not having fire as the fuels start building up. These young trees begin growing. Why is this? It's because if fires come along and clear that stuff out in the past, now we fight it like an army. It's a militaristic operation. And I love to quote our ex-governor, Judy Martz, who said in 2001, in her State of the State address, after the fires of 2000, she said, and I quote, "We survived one of the," what'd she say? "We survived one of the worst disasters in the history of the state of Montana." And then she said, and I quote, "Never before on American soil has such a large army fought a single enemy." So this is our thinking. We're on these things, and we put them out. And we're pretty darn good at it in the low severity zone where the fires are pretty mellow. We're not very good at it in the higher severity fires, as we'll talk about later. But there are other things that turn out to be more important than fire suppression in causing fuels to build up. One is cattle grazing. Around the turn of the century, we were hammering public lands with cattle. And so here in 1893, the governor of Arizona stated in his annual report in nearly all districts, owing to overstocking, many weeds have taken the place of best grasses. Then Cooper, a famous ecologist in 1960, said conditions were probably at their worst by the turn of the century. And heavy grazing reduced fire frequency to an extent that many of the early arguments against removing livestock from national forests was based on the premise that heavy grazing made fire less frequent. Everyone knew that cattle had a big effect, and what they're doing is eating the fine fuels. You don't get fire. They don't like the little trees, so the trees come up, so the fuel builds up, but you take out the fine fuels. And then there's timber harvesting. Fire-resistant ponderosa pine and western larch have the greatest commercial value and were most likely to be removed early on at the turn of the century. So there's a lot of things we humans have been doing, not just fire suppression, and probably fire suppression is less important than these other two. Here's a neat graph from Eastern Oregon that just came out just a few weeks ago. Here's a typical plot that's thought to be out of whack, and this is a distribution of numbers of trees of different ages. And you see most trees were born, germinated around 1910, so they're all about 100 years old, 190, 80. Hardly any older than that, hardly any really younger than that. So for some reason, there was a big pulse of trees around 1900. What happened? There was high-grade logging 15 years before. So this logging, and there was livestock grazing, and of course fire suppression supposedly started, but that was basically very ineffective until the 30s or 40s. So you see, again, suppression is probably not what's going on. It's probably logging and livestock that caused this big pulse of recruitment in trees. If it were just suppression, there'd be babies coming up all the time. So here's the story. Forests are maintained by low-severity fire, and forest understories are kept clear because this fire comes through. But overzealous fire suppression and grazing and timber harvesting probably allow the fuels to build up. Now when a fire comes along, it's unnaturally severe. Has everyone heard this story? My God, we've all heard this 1,000 times by now. There's widespread belief that things are really wacko at this point. The fires we're seeing are unprecedented and unnatural. So there's a lot of authors that I could point to that say things like, and I borrowed from one of them, that this kind of thing we're seeing now can set the whole forest on a trajectory to something permanently unacceptable. The General Accounting Office also says the overaccumulation of vegetation is causing catastrophically destructive fires. And Smokey Bear page, if you go on today and read it, wildfire is one of the most destructive natural forces known to mankind. Is that true? Is this unnatural? Is this unprecedented? What would you do if you had to answer the question yourself? What we need is some sort of indicator of biological integrity, some sort of indicator of the forest health. Any group of animals or plants would work really well to answer that question. You just go out there and see, is it really a sea of death and destruction, or is there something there? Well, you could use any group of animals, little mice or insects, beetles, flies, snakes, whatever. But what's interesting is most groups of organisms are really hard to detect, and they're hard to identify as species. Most of the time you get an insect, you can't even tell what species it is anyway. But that's not the case for birds. Birds are the most visually conspicuous vertebrates on the planet. Not only that, you can cover your eyes. I can tell you it's a bird. I can not only tell you it's a bird, I can tell you it's a western meadowlark. It's not only telling me it's present, it's telling me its name. I mean, name another group of organisms that does that. Birds are hands down the most phenomenal environmental indicator tools that we have. And the other thing you can do with birds is stand in one place and get information from 200 species as easily as you can get information from one. Phenomenal group. So let's play the game. Here we are in a forest. We're going to go out and you do a formal count. 10 minutes, you can record everything around you within, a football field or so, right? So you just stand here and you're waiting. Oh, good, all-sided flycatcher. Wow, see? I told you, you don't even need equipment. Pine siskin, somebody said. Coming to your feeder? Junco, good. Hey, come on, we got some birders here. Robin. Some kind of woodpecker. You get the idea? It's so amazing. It's so amazing. Birds are so cool. When I teach ornithology, now I'm retired, so when I taught, I would tell my students the first day, this is a scary proposition. If you like your world the way it is, if you're happy walking through the woods, everything's in place, everything is fine, you don't want your world to change, then don't take this course. Because it's going to change. And here's the bad news. It's a one-way street. There's no going back. There's no going back. Your world will change. And if you want your world to change and you're not into this yet, Sue and I, my wife Sue, and I are going to do a Molly course in June for beginners, total beginners, beginner bird watching. It'll be, I think, when is it? You sign up in May or something like that. So we went out after the fires of 1988 in Yellowstone and started going around to different fires. And it was such fun. We got married the year after that. So we went around. We went to probably 45 different fires that burned in 1988. And here's what we found. Lots of birds. So the first thing we found was, whoa, this is pretty impressive. It's not like a big desert. It's not a sea of death and destruction. There's a lot of stuff out there. And not only is there stuff out there, over 100 species, most of them are actually nesting out there. What? Nesting where? Well, in the trees, mostly. Some of them are on the ground, like the junco, but everything else, like that wood pewee and the swallow and the woodpecker and the robin, they're using the standing dead trees, the legacy from the past generation passed on to the future forest. And the third thing we found was that many species, about 15% of them, are nowhere more abundant than in burned forests. Like, where else are you going to go to see them this abundant? And how do I know that? Am I going to spend my life going around to every possible kind of vegetation type the Earth has to offer? No. What you do is go first to a museum like this, like the Phil Wright Museum, where you got, you know, new dead birds, old dead birds, fat birds, lunch. And it turns out museums, often when they went out on collecting expeditions, they would keep records of all the birds they'd see in a particular vegetation type. So this kind of information is available. You combine it with citizen science, where people record birds that they see in breeding bird surveys. And you get that information, you put it together, and you can calculate the probability that different species occur in different vegetation types. So I did this for about 9 different vegetation types. So you have grassland, sagebrush, riparian, aspen, mixed conifer, spruce fir, thin forest, clear cuts, and burn forests. And here's 2 of the 15 that are more abundant in burn forests than anywhere else. Robin, yeah, robin, it's a forest bird. It's not in grassland and sagebrush, but nowhere is it more abundant than in burn forests. Blackback woodpecker, nowhere is it more abundant in burn forests, and more than that, you don't even see it anywhere else. It's amazing. Well, of course, when I got thinking more about this, began wondering, well, you know, and a lot of people said, you're missing a lot of vegetation types. You know, not only that, you're combining apples and oranges and different methods and collectors and citizen scientists, and oh, you know, it's like, you don't know what you're looking at. And so I thought, well, we need to hire an army. And so now, over the past 20 years, University of Montana, we've hired over 185 people to do surveys, undergraduate and graduate students, of birds all over Idaho and Montana. We now have about 18,000 to 20,000 points scattered throughout the area in every conceivable vegetation type. Parking lots, cities, you name it, we've been there. We know what birds are there. And so now I can take the data from a systematic method, okay, compare it and see what the blackback woodpecker looks like now, right? Well, here we go. There's a bunch of different vegetation types. It sticks out like a sore thumb. We were not deceived by our earlier data. It's basically a burn forest specialist. This is an indicator species. It indicates that particular environmental condition, burned forest. So the next step is, okay, you convinced me they're in burn forest. Well, what kind of burn forest? When you go in there, are they lurking around in this mostly green stuff, or in the green-brown, or the mostly brown, or the brown-black, or the mostly black? Are they in this stuff that's totally out of whack over here? Or are they in this stuff over here? So if you record the severity of the fire at each point when you do an account, you get data that look like this. They're in the hot stuff. They love it hot. And then people could say, well, wait a minute. Now, you're not showing me abundance of bird. You're showing me how often you detect them. You're just missing them over here. They're lurking in the forest, you know, but you don't detect them because it's all green and they're hidden and it's wide open in the burn stuff. And so you go, oh, God, you know, there's always something that comes up. So what you can do is you can play a woodpecker drumming sound, and if it works, yeah, you little dog. That's a woodpecker drumming. And it hears it, thinks another male's in on its territory, so it comes in to attack the speaker. So you can be anywhere, whether it's closed in green or open and black, and you get data, right? And now nobody can argue that we missed anything. And there's the data from the playbacks. It's more impressive. Data from the playbacks are even more impressive than those from the regular point counts. Apparently, some like it hot. And this has been kind of known informally for years. 100 years ago, reference to blackbacks, Manly Hardy wrote Major Badir in 1895. Specimens were so abundant when I was short for material for stew, I shot the heads off 6 of them. And the more I think about this, the more this story becomes just, it's amazing. It's the most amazing thing to me since understanding natural selection and how natural selection works. Once you get that, it's like, oh, it's like you understand, it feels like you understand everything. This, to me, is the same kind of experience, the same kind of aha. When I see that blackbird against that black tree trunk, that's no less impressive to me and doesn't reflect any less of an evolutionary history than this white bird against the white background. It's fire. It's screaming fire. And what do? They come in to eat larvae. Beetles come in because the trees are dead. But there's good wood beneath the charcoal bark, right? So the beetles come flying in, and then the birds come in to eat them. You can hear the beetles down beneath the bark chewing. So the beetles are actually chewing away, and the beetles themselves are totally restricted to these burn forests, many of these species. This one, Melanophila, the genus Melanophila, black lover, they have infrared detector on the thorax, this heat sensor. They can detect heat for up to 100 miles away and come flying in and lay their eggs before the trees are even done smoldering. And then there's a paper that was in Nature on these longhorn beetles, and the longhorns, what are those for? Well, they can detect tiny concentrations of smoke in the air. So you have all these cool biological adaptations for a process that has been around since the beginning of time. The story of these guys is so cool, I like to tell. How am I doing? Okay. Is an article in 1943 by Lindsley. He says, oh, yeah, at Berkeley football games, it's so cool. In Memorial Stadium at 1940s, there were 20,000 cigarettes lit at any one time. And that the smoke coming out of the stadium would attract these beetles. They would alight on patrons and bite them and annoy them more than a Stanford touchdown. So the beetles come in, and then the birds come in to get the beetles. That's why the woodpeckers are in there. So here's all the wood has been riddled by woodpeckers digging in there for the beetles. So this is what the forest comes to look like after a year or two. And here is the star of the story. You want to see a little quick video clip of a blackback woodpecker?
Oh, this is the hero of our story, male blackback woodpecker. Jet black on the back with a brilliant yellow cap on top of his head. Used to be called the blackback three-toed woodpecker. I can even see here with these 10-power binoculars that there are 3 toes pointing upward.
Is that one cool bird or what? This is a poster bird. It's a poster child. And it really reflects severely burned forests well. And what I want to say is this is not about blackback woodpeckers. It's not about bird conservation. It's about listening to what the birds are telling us about things that are bigger than birds. And it's not just the blackback that show this sort of pattern. Here's the American three-toed woodpecker that also is no more abundant than in burned forests post-fire. And it likes it hot. Here's hairy woodpecker that's also no more abundant than anywhere than in burned forests, and it likes it hot. Here's flicker that's very abundant in burned forests, and it likes it where it's hot. Here's mountain bluebird. Have you ever seen a mountain bluebird in the real world, away from a nest box? I'll tell you where you've seen it. You're more likely to see it in a burned forest than anywhere else. And where? In what sort of toastiness? Super hot. It embarrasses the woodpeckers the extent to which it likes the totally severe stuff. And so, that's just the earliest stage. We could play this game, at every one of these stages. And we'd get a different set of critters. If they're restricted to any one of those stages, then the only way to renew that stage and make it good again is to burn it, back it down to stage 1 and wait for it to come again. And so everything that's restricted to any of those stages, you could call a fire-dependent species, if it depends on disturbance to create those conditions that it needs. And so I've looked at Black Mountain here that burned in 2003. Now it's year 12 coming up. And I'll show you some data for 10 years that hints that some birds are just coming into where it really is getting good. So here are some data for 4 species. The one on the left there is outside the burned area. So a 100-mile radius around Black Mountain here west of town. We took points that we had from the land bird monitoring program, so it's so cool. We got all the data just sitting there. And we say, what's in a forest that's just like this at Black Mountain, or Blue Mountain here, but not burned? That's that line. Okay? Then here's the first 2 years after the fire, second 2, third 2, fourth, and fifth set of 2 years. Okay? 10 years later. Townsend solitaire loves it right away after fire. It's more than twice abundant in a burn than outside a burn. Okay, same with robin. Likes it, and then it begins to fall off. Here's a bird, mountain bluebird. Boom, loves it, and then stays pretty high. Western bluebird comes in, loves it, and loves it more and more and more with time. And then there's a few more that don't like it until later. I haven't been getting these things until the last couple of years. But if you just went out 1 or 2 years after, like this Williamson sapsucker, you'd say, oh, they hate fire. They're much less abundant after. Oh, well, the poor Williamson sapsucker, oh, it got hurt by the fire. Well, no, it didn't. You haven't waited long enough. Hold on to your horses. It's getting phenomenal with Williamson sapsucker in there right now. And so Dave Patterson in mathematics helped me try to visualize this. And he says, look, we'll plot any one of these squares. Here's low severity, medium severity, high severity, and here's time, early, second, third, fourth, and fifth year after fire. And if it's significantly more abundant in the burn than outside the burn, we'll make it, the z-score is higher, it's dark red. So chipping sparrow loves it early after fire, loves it hot, right? And then these are all different bird species. They all love it, love it, love it, love it, love it, love it. Every one of them has one spot at least where it really likes it. The blue, they don't like it. It's negative. This hermit thrush does not like fire by and large. But maybe if it's low severity and maybe a couple of years after, whoa, now we're getting interesting. And so you go through all the species, there's only 6 out of 50. So 88% of all the species for which we had enough data to do this love fire at some place or another in time and severity. So the story is, this is the environment against which these things evolve. This is important to maintain, and this is the environmental backdrop against which these species evolved. So the implications are clear. It's not that these things survive fire, it's that they need fire to survive. So I hope what I've shown you is kind of changed your perspective of the story of fire and what we're always told. Because you have to turn 180 degrees from what we're often told about fire. I like to think of this as nature's best kept secret. And I think what's happening here when you ask, well, who's right? The birds or these people telling us the forest is out of whack? And the answer is, they're both right. The problem is, the people that are saying the forest is out of whack, it's in a very small kind of forest type that's relatively rare. But yet they've used words in their publications to imply that it's much broader than it really is. And so you see things like the historical and anticipated changes of forest ecosystems of the inland west. We're talking about forest ecosystems of the inland west. We just left the ponderosa pine, now we're talking about the west? This one here, the prognosis is poor for U.S. forest ecosystems. Now we're going over the whole United States. There's no data in support of that. And so the problem is really much more limited than what the press leads us to believe. As long ago as 1943, people were beginning to question that things are being overblown a bit. So Arthur Brown responded to fellow Weaver's assessment of ponderosa pine forest being out of whack by saying that overstocked and stagnating stands seem so far from typical of the region for which he speaks, Arizona, that one wonders if Mr. Weaver is not generalizing a bit too much from a single area. And then Baker in his cool book on fire in the Northern Rockies, same thing. There are unnaturally high tree densities in some places, but certainly not everywhere. Fire scar studies are drawn from a very non-random and biased sample. If you want to ask a tree fire history, you have to go to a place that doesn't kill the trees. It's a very biased sample. And so the story may apply to these ponderosa pine forests that are very dry and generally have frequent low-severity fires. But that's 10% of all the forests in the West, something like that. Here's a map of them. It's not a lot. A lot around Flagstaff, the largest extent of pure ponderosa pine in the world. Look at Missoula. Hey, come on. This story doesn't apply around here. So fuel buildup is not responsible for severe fires we see, any more than it was responsible for the fires of 1910. And those are the result of climate and weather. Severe fires are driven by weather, not fuel. And if you look at 4,000 fires and just say, oh, red is severe, this gray bar is medium severity, and the green is low severity, Very few forests are 100% low severity. Everybody has a little bit of high severity. Everybody. You might say, well, how do we know that plot there of 4,000 fires aren't biased because everything's out of whack? That's why you're getting all the red lines. We know for two reasons. One, the birds are telling us. The birds, the beetles, the toads, the morels, the geraniums, everything is telling us that severe fire is an integral component of most fire regimes. Are you listening? The second way is you can get records of when severe fires occurred, just like you can get records for where low severity fire occurs. You don't ask trees, you ask the lakes. And so you can go to a lake around where things burn severely, and the ash settles at the bottom, and pretty soon you get a layer of charcoal. And so people like Kathy Whitlock here from Montana State, she does this sort of thing. You get a core, and you look at it just like a tree ring thing. And she can count charcoal, and they can go back thousands of years, not hundreds. And she can say how many severe fires occurred in this area in the past. And when you do that and plot it next to this curve for the low severity fire, here's our low severity fire thing. Here's the gray where everything shuts off in 1900. Here's charcoal records, and you don't see any kind of pattern like that. They've been around forever, and they're not any more abundant now than they ever were. And if you look at what's cool about it, here is the charcoal record, and here's a peak. Voom, ja, wang, jang, wang, wang. And then here is drought. Zoom, wang, 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 wang. It corresponds perfectly. These are weather-driven events, not fuel-determined events. It turns out most of the area that burns in our forests are from a very tiny percent of all the fires. So if you just say, let's take all the fires that burned this year, we're going to rank them from the tiniest, 1/100th of an acre right here, then the next biggest, then the next biggest, then the next biggest, then the next biggest. Let's line them all up from the lowest, from the smallest to the largest. Here's what it looks like. This is the real data. You go all the way up to 98% of the fires, you've still only covered about 2% of the land. The last 1% or so. And those are not controlled by fire suppression. So we're very good at keeping small fires small. We're not very good at keeping large fires, keeping small fires from becoming large. Oh, that's that one. So this fuel buildup idea has been uncritically and inappropriately applied to some ecosystems, including most mixed canopy, mixed severity forests like around. Hello, okay. So the severe fire component we see in most forests is well within the historic range of variability. And probably when we see a severe fire like that, it doesn't mean the forests are out of whack. So when we get a severe fire, right, we should be dancing in the streets. But we don't. Why? Because since we're born, we've been raised on this. We're told that, this weakens America. Then we have comic books we read as kids. Smokey Bear grew up as he tells something to folks. He still tells them the same thing. He tells them how he hates forest fires, how they destroy his animal friends, how they burn up timber that could have been used to make homes, perhaps a new home for you. They waste wood that could have gone into furniture, even to make paper to print comic books on. This is what we all grew up on. And you say, well, at least that's in the past. No, here's the billboard near 3rd Street by the Good Food Store just a few years ago. Unfortunately, they can't run for their lives, it says about the trees that have been waiting for 150 years to have reproductive success because of the fire. There's no ecology. Where is the ecology? And so whenever we see a fire without ecology, what do? We see words like horror, disaster, devastation, destruction, crime, scar. When Yellowstone burned, this is exactly what we read and what we heard. It's the most beautiful fire. Look at it. The mosaic. It turned the most boring park in the nation to one of the most interesting parks in the nation. But if you look at the news, it's so cool to go back to the news. You want to see? This is New York Times put this together.
Part of our national heritage is under threat and on fire tonight.
Our oldest national park is under siege tonight.
The president to declare Yellowstone National Park a national disaster area.
In the summer of 1988, wildfires burned through nearly a third of Yellowstone National Park.
There are a lot of angry people who believe that the National Park Service let the fires burn too freely for too long.
It's always somebody's fault. So even though fires are natural and necessary part of ecosystems in the western conifer forests of the United States, we're led to believe that they're very unnatural. So you get that one? Ooh, yeah, yeah, yeah. But wait, you know, if severe fire, even if it's natural, okay, even if it's natural, shouldn't we be prescribed burning or cutting or things to protect ourselves and protect our homes? Well, most legislators apparently think so because we've passed laws to try to expedite that activity. So we have the Healthy Forest Restoration Program, and we have the Omnibus Managed Forest Management Act to address threats of forest health, including catastrophic wildfire. We're going to try to stop these fires. Unfortunately, thinning doesn't stop the fires that burn 98% of the land. Here's a picture I took of Plum Creek land near the Jocko Lakes fire up in the Sealy in 2007. It burns right through that stuff. And you can get example after example after example. Logging and thinning didn't slow Idaho's elk complex fire. The timber sale completely burned up, says Dave Olson, Boise National Forest. Here's this a cool one. Experimental plots in Flagstaff, where the birth of the story came from, where you have experimental plot thinned and not thinned over here, and one side treated, the other not. When the fire hit, it didn't matter. The intensity of the wall of fire was just so massive it was whipping through trees, didn't care how continuous the tree layers were. Thinning doesn't stop the fires that burn 98% of the land. And it doesn't stop your house from burning down. In addition, this is really interesting, contrary to popular belief, thinning and prescribed fires don't prevent houses from burning down. It's usually embers and things that blow in after the front has gone through and nobody's around to squirt it out with their garden hose. And also, you can be surrounded by trees and not have your house burn down. It's all about home safety and being fire safe. And the champion of that is Jack Cohn, who's done all the research on this, showing here at the Fire Lab, and Andrea Sippard, or Alex Sippard down in San Diego, and C.J. Fotheringham at UCLA. All those folks have tons of data that show that what determines whether a house goes or not has nothing to do with the forest out there. It has to do with what's right around your house. Usually pine needles in a rain gutter, that kind of thing. And Jack Cohn, he's got a great video if you go online and look at Cohn's stuff. He shows this fire burning right outside this house, and there it is after. It doesn't necessarily mean the house is going to go. The house can tolerate that stuff if everything else about it is proper and in place. So, if severe fires are going to burn anyway, no matter what we do, and we can't put them out, and we can learn to be safe, then everything's fine, right? If we just get that, everything's fine. But there's one last thing that's a problem, and that is most people believe since there's no value in a burned up forest because we've never been taught there's any value, we may as well go in and harvest it all. And so 89.5% of us who were surveyed in the Bitterroot after the fires of 2000, that's 90% of us agreeing on something. That's phenomenal. That is phenomenal. We agree we ought to get in there and harvest that timber. So we do. We salvage like there's no tomorrow. And then legislators pass legislation to try to expedite the salvage without any environmental review because, of course, there's no reason to. There's no value in that. But wait, don't we really want to cut these forests in the aftermath if they're so special? Probably more special than old-growth forest in terms of the kinds of things that occur there? That's what the birds are asking. If you go out and do this, and go do your bird data so you can go out there and do your counts and ask the birds, and there's a lot of published literature on this now, and it's 100% the same. So in one of my papers I actually say, I'm hard-pressed to find any other example in wildlife biology where the effect of a particular land use is as close to 100% negative as is the typical post-fire salvage logging operation. I'm telling you, this is the facts. This is not advocacy. I'm not advocating a decision. I'm advocating using science to help make a decision. I'm unabashed advocate for using science. I'm not advocating a particular decision. And so now we have the issue, a high-profile issue. Outside Yellowstone, this is the rim fire that burned a year and a half ago. Beautiful. Look at that. Can you imagine a better fire in terms of low, medium, and high severity? It's gorgeous. But everything that came out, this is only a year ago, rim fire, burned area, see unprecedented destruction, plant life unparalleled, unprecedented barren moonscape, leaves destruction for the ages. And sure enough, you're going to get legislators who are going to come out and try to pass bills to expedite the salvage of it. So I tried to, tried to spar with this guy a little bit, and here, I'll play a little piece of it here.
Plan is expected to be finalized.
Oh, that's not it. Have to get back in a minute. How do I get back to the start?
University of Montana professor Richard Hutto says the forest should recover naturally, and snags, or burned trees, attract legions of insects that in turn feed wildlife like the black-backed woodpecker.
Some of these species are fairly restricted to these burned forest conditions. If you don't leave these places alone, there's nowhere else for them to be.
The Forest Service plan is expected to be finalized this summer, but Congressman Tom McClintock, a Republican whose district includes the burn area, says that's too late. He introduced a bill to expedite salvage logging by suspending the environmental reviews.
What the left wants is a policy of benign neglect. They want to let 250,000 acres of destroyed timber rot in place and surrender the ravaged land to beetles and watch as the forest ecosystem is replaced by scrub brush.
Right. That's succession. And it wouldn't be so bad if it weren't true that there's a lot of other places for us to get timber. It's a renewable resource. Good grief. There's plenty of places to get timber. This should be the last place, not the first. And so now that bill died in the last session. Yoo-hoo. However, so you got to go through the regular process, so it's going. Right now, the 60-day comment period is on right this minute. And there's the proposal. Let's cut all the trees where all the red was. It's interesting. It's just really fascinating. We went down, so my wife Sue and our son Paul and I, we went down last summer, and we're standing listening to the Forest Service. They were giving a tour. And they were talking about, unprecedented worst. Oh, this has never happened before in the history of the earth, and it's so bad, we better do something. And so we're sitting there, and right behind the gal who's speaking are white-headed woodpeckers, which are also cool fire-dependent things. And I'm going, oh my God, white-headed woodpeckers! Everybody's just totally oblivious. It's pretty interesting. So again, my point is there's plenty of places to get timber. That's not a problem. If you're worried about the local mill and you want to boost the local economy, go boost the local economy. Just don't do it on the back of something that's restricted in its distribution to a very special place. Here's Blue Mountain. Look at it. This looks great. Nobody complained about that. It's fantastic. There's lots of things that need severely burned forests. And I think the birds have spoken. And it's not just the birds, it's everything from morel mushrooms. Where are you going to get those? Where do you think they get those? So the story is this is a beautiful thing. We have to learn to appreciate these things as much as we appreciate old growth. We have to take an ecological perspective to get away from the old lady destructive death and see the young, beautiful forest, right? So as a student of nature, your job would be to help share this ecological perspective. And there's ways you can do it. There's even children's books that can help. Oh, here, yeah. This one just got published this last month by Sneed Collard, who's an author here in town. I suppose you can pick up at your local store. It's got, the whole story, just like we told you. And it's even got, there I am. I'm in there. And then there's Beth Peluso. She was a graduate student in environmental studies. Awesome book. Every page has a blackback hidden somewhere. You got to find it. These are written pretty much targeted for legislator age. So let me, before I open up for questions, that we're about there, right? Hey, okay, good. We're just about on time. One thing I like to do is just show you a series, a little slideshow of pictures I've taken in severely burned forests. And the story is, gee, isn't it cool? But if you cut it all down, there goes the magic. Okay, that's the story. And it has music, so when my wife and I are at that movie, darn it, now I can't think of the name of it. Anyway, there was a cool song that came on with Mark Cohn. So I wrote to him in New York, said, can I use your music? One Safe Place sounded like, it's probably about some drug addict or something, but I said, I like One Safe Place. I want to make a fire video. And he goes, geez, what a weirdo. Okay, go ahead. So he let me do it. So let's see here if this works. I'll get rid of the PowerPoint. Hope this works. And then try this thing. Okay, so it'll be one song's worth, about 3 minutes.
How many roads you've traveled, how many dreams you've chased, across sand and sky and gravel, looking for one safe place, yeah. Hey, one safe place, yeah. Will you make a smooth landing when you break your fall from grace into the arms of understanding, looking for one safe place, yeah. Hey, yeah. One safe place, yeah. Oh, life is trial by fire, and love's the sweetest taste. And I pray it lifts us higher to one safe place, yeah. Hey, yeah. One safe place, yeah. One safe place, yeah, hey, yeah. How many roads we've traveled, how many dreams we've chased, across sand and sky and gravel, we're looking for one safe place, yeah. Hey, yeah. One safe place, yeah. Hey, yeah. One safe place, yeah.
Happy to try to answer questions.
Hands up and we'll get a mic to you.
One of those early slides that had the cross section of the tree with the fire dates. How did you know what the dates were?
You count back from when you cut it down.
I mean, how did you know what year?
Yeah, so each, the tree puts on annual growth that slows down in the winter, then speeds up in the spring, then slows down and speeds up. And so it leaves rings that are evidence of a year in age. So you simply count the rings. It's backwards, so you start from the 1974 when he cut that tree down, and you went all the way back to 1610 or whatever it was. And then you cut lots of different trees, and you find fires that are congruent. You know, oh, here's the 1671 fire. Oh, here's the 1612. Oh, here, and you can line them up, different trees, and go back farther and farther and farther in time if you can find really, really old trees, and get a composite index.
Could you say something about places where there's a lot of dead trees, but not because of fire, like the beetle kill up by, Helena, Lincoln?
Yeah, don't know. Vicky Saab of the Forest Service Research is working on that particular area in Helena. And I haven't heard from her anything special. In my own personal experience going into beetle kill areas, there's not quite the magic. There's just nothing, there's a few things that show it's just not the same. So if I had, to pick between cutting in a burn forest and a beetle kill forest, somehow we had to do one for some reason, I'd certainly point to the beetle kill long before I'd point to the fire. But this is one of these things. We know so little about the importance of these natural disturbance events that I hesitate, to do, something that cleans it all out without really knowing what in the world we're doing. Yeah.
How about the bark beetle infestations? How does that figure in here? Because forests that are thinner are less acceptable to bark beetle, or at least that's what we're told.
Yeah, well, it's complicated. Turns out there's very little interaction between bark beetles and fire. So there's some cool papers coming out of Colorado where they show that they're very independent. It's not like when beetle kill comes and the trees get all green, then fire comes. No, they're very unrelated statistically. So that's the first lesson. Then the second part of the question, now I've lost myself because I'm retired and I don't really think very clearly anymore, but what was the rest of the question? What was the last part? Oh yeah, thinner forests. Yeah. Thinner forests. Yeah, so the trees would be healthier, less likely to get beetle outbreak. That's probably true. But then Bill Baker just came out with a paper. It's not out yet. It's just to be published any minute, where he shows that thinning some of the younger trees actually can do damage in ways we never thought. He says those make the whole forest less susceptible to beetle outbreak, and often they'll take on a lot of the beetle and leave the adults sort of alone, and so it's throwing things out of a whack in a way that we haven't really understood very well. That's all I know on that. I don't know much about the beetles. Diana 6 would be the one to talk to on campus for sure. Sure.
There are unique plant species that are fire dependent, and they last only a very short time, some of them.
Mm-hmm.
And so I'm wondering about in terms of fire and the interaction between birds and the plants that are very fire dependent. Some things will lay dormant for centuries and then show up.
Mm-hmm.
And I don't know the specifics, but I remember learning that from somebody.
Yeah, certainly around here, one of the champions is Bicknell's geranium. Sit in the soil for 150 years as a seed. Or dendromecon, tree poppy or something like that in the chaparral. These little cute little round seeds, they just sit there when the chaparral fire comes through and pow, they're out. It's amazing. But as far as I know, no interaction with birds and those specific plants that I'm aware of. The really interesting thing would be pollinators and pollinator community, because many of these things end up being, some of the magic are annuals even, and we don't know enough about interactions. But Laura Burkle is starting to work on that out of Montana State. She's doing pollination ecology and in burned areas. Very few people have looked at that. In fact, yeah, it's another one of these nature's best kept secrets probably. We probably have a lot of native bees and things in there that we don't even know about. Yeah.
If after a large fire you went in and cut every other acre or every other section, would that reduce the bird population by half, more or less? Do you have any idea?
Probably, that would be my guess. That would be one approach. If for some reason our hands are tied and we feel like we have to do this, yeah, take some and leave
Might
some.
satisfy those congressmen who want
Yeah, yeah, you know. And if we took some and left some in all the elevations and all the styles, and yeah, then at least we're kind of hedging our bets a bit. But the more I think about it, and I came out in my first paper I wrote on this, that's what I said. I said, geez, I don't know if I had to recommend, take half, leave half, kind of thing. But in the years since, over 25 years, I've come to believe, why are we in there at all? And the other thing that bothers me about being in these burned forests is there's so much going on in terms of the new plant community coming along. And there's so much unpredictability. And when we go in, we'll tend to want to homogenize everything, and then we end up planting, and now we have a tree farm. And what is our public land? We've got plum creeks over there. That's fine. That's their business. But our public land, to be mucking around in these areas where we know very little about what determines the trajectory of the next generation, I'm saying, my feeling now is, why are we in there? There's so many other places to go if we need wood. Yeah.
I've done some work in post-fire soil ecology in different forests, largely in the southeast though, and I was looking at fire severity in terms of temperature, increase in temperature and charring further in the soil level.
Yeah.
And a lot of that's being attributed to climate change, and so if you have any thoughts on either of that or...
No, I don't know much about trends in average severity or intensity, the actual heat release per meter squared, that kind of thing. I don't know if there are any changes in the actual severity. My gut feeling is the actual severity of the fire burning through is not any different than it's ever been. And if you get a really hot spot, it was because there was a bunch of fuel in that spot and the winds didn't blow it away and it stayed and burned for a long time. But I don't know enough about that. Sure.
Hi. So as far as the big fires go, how long do you notice does it take for the bird species, such as the woodpeckers, to come into the area as far as like days or weeks go?
Yeah, cool. You got an interesting question there. You hit on one we don't know. What we do know, people publish some things when they see these blackbacks really soon, and it's been in the months. Like, holy cow, there's a blackback here, you know, that kind of thing. And now with all the citizen scientists and eBird and that stuff, we're really on it. If somebody shows up in a fire like the Lolo fire here a year and a half ago, a bunch of us were out there within months. There was a we couldn't believe it. You know, my wife Sue and I are out there, and oh my God, there's a blackback. So do they come up out of the soil? What? And so no one knows how they get from one fire to the next. We've banded a lot, you know, over 60. We've never found one in one fire, gone to the next. People have radioed them, and not yet has anyone seen one go from one fire to another, but I suspect they're semi-nomadic. They'll hang around for a few years. The food resource starts falling off, and they take off and go find another. You know, if we stood outside in August and spun around, we'd see a smoke plume somewhere. It's no problem to go fly over to a new fire. So they're probably kind of doing this sort of thing, moving into these areas, but we don't know. They're certainly in there within the first year. Yeah.
Since we've suppressed the really severe fires for so long, are the populations of the fire-dependent birds down?
No one knows because they're so, you can't survey them very well because they're so spaced out. And the first part of your question, we haven't been successful in suppressing the severe fires. 0 success. The most amazing data come out of Canada from a fellow named Mayanishi and Johnson. And they published this thing where in Northern Ontario, they don't suppress fires. Southern Ontario, they do. And then they said, let's just line up all the sizes of all the fires in the two areas. And sure enough, you see a lot more small fires where they suppress. we're really good at keeping small fires slightly smaller. But as soon as you get to 40 hectares, that's only 100 acres. From 100 acres up, there's no difference in the numbers of fires in each of the size categories between suppressed and unsuppressed. We're not effective at putting out severe fires. They will do what they want, when they want, and this leads to all sorts of interesting thoughts if we go down that track. Yeah?
I was wondering about the short and long-term effects of these chemical fire retardants on the ecosystem.
Boy. I don't know the answer, but people are beginning to look at this sort of thing, and most of the information people find, it's not a great thing. The chemicals are not great if you're a native plant. Yeah. It tends to be more localized, so maybe that's not all that bad.
The data on the Lewis's woodpecker was fascinating. It wasn't in the
Yeah.
burn at all.
Yeah.
And I always tend to think of them as a riparian species.
Yeah.
So do you think there's pressure in the riparian areas that's combined?
No, I think they've always been both. Riparian and low elevation ponderosa pine, and when a fire comes, they kind of move back and forth. So those are the two things they really hone in on. Bottomland cottonwood riparian and the lower elevation burned forest. And what's happening and why it takes time, I think, is after 10 years, the big trees begin to break and crack, and they're a weak excavator. They're not they can't dig like a blackback right into a lodge pole. And so these trees have weakened, they begin to break, and they're big trees. So now in Black Mountain, where are they? They're up slightly higher where you see some of these big trees that were left, and they're just in heaven up there, apparently. So it takes a while for the conditions to get good. The same thing with with Williamson sapsucker. They're weak excavators. They need this blowdown sort of period after 5 or 10 years. Then they begin showing up.
Are there any studies about fires in non-forested areas like sagebrush habitats?
Yes.
That there are birds that are fire dependent in those kinds of ecologies?
Sagebrush, not so much that I'm aware of. Every other vegetation type where fire is common, yes. So you go to Australia and the eucalypt forests, and there's little robins that pounce, like that's what bluebirds do. Bluebirds are pouncers. They sit and they pounce on grasshoppers and things. So there's a little thing called a robin, and you look at the early years after fire in Australia, and the robin population's through the roof. Or you go to South Africa, there's specialists there on the fire. You go to the chaparral. It's kind of interesting. It proceeds so fast that there aren't as many specialists in the very early stages in the chaparral. But yeah, most fire-dependent communities have these kinds of interesting things going on. The sagebrush. The sagebrush system's kind of way out of whack. There's another one that probably is out of whack because of the cheatgrass. It probably is burning more frequently than it ever did, and I don't understand that system well enough to know it.
I'm just kind of curious when you say a robin in Australia. So I know that we have the American robin, the American red-breasted thrush, as they say in, say, like the UK.
Uh-huh.
And then there's the actual European robin. Is that an actual robin species in Australia?
Different genus, yeah, it's a totally different genus. Okay. And I can't remember. Anyone know? Eric, you know that? Different than the European. But for some reason, they like the red fire. I don't know. It's like that tanager with the red head. You see one in a burn, it's like, oh my gosh. It's like God put this thing down there. Whoa, the flame head. Whoa. It's like, I like fire. Yeah. It turns out that western tanager is what I call the Goldilocks bird. It doesn't like the really high severity. If we went back to that slide thing, I'd have to look. And it doesn't like unburned forests as much as the low severity. Not too hot, not too cold, just right.
What are your thoughts about resistance to science?
The question was, what are my thoughts about resistance to science? It's consuming me in retirement. And toward the end of my career here, I began thinking more and more and more about this, because if any of you came to the talk 15 years ago, it's basically the same talk. And so it got me thinking, why am I so ineffective? Can I jump up and down anymore? What do I have to do? And so part of it's the effectiveness. The science I'm not worried about. No one's ever questioned the science. Okay? But it doesn't get used. No one's listening to it. And most of my time has been consumed talking to the wrong audience, probably. I mean, this is a great audience, but it's not the right audience to affect change. And so I'm trying new things. I've been workshops, an NSF workshop, and another one's coming up called the Compass Workshop. We're talking on the phone now, but I don't want to travel. So they want me to go to Washington? No. They want me to go to Denver? No. I said, you come here to Missoula, I'm ready. And what they do is train you to make contacts with the right people. That would be like Senator Tester and Daines. And so I've written to Daines and Tester, and Daines wrote back. Not Daines, but staff. And so, you know, and then I went into the field with the new forest supervisor here, Tim Garcia, who was really gracious, saying, yeah, let's go have coffee and we'll go out in the field. And so I feel like, you know, I'm not making a decision for him, but I feel I'm comfortable now that he knows the information, that he'll use that information in making whatever decision he makes, and I am happy with that. If he decides to go harvest that, I'm happy because he's considering this information. Most environmental impact statements, you won't see one word about the benefit of a severe fire. And so that's where I'm trying to go with this.
Well, so that's related to my question in terms of the legislature and you know, the newspaper article about all the money that's being cut from the Forest Service, and it's all going into just fighting fires.
Yeah.
So they can't do most of the rest.
Yeah, yeah, it's a real shame. So over half of the Forest Service budget, annual budget, goes to fighting fires. And as my wife says, you know, we hardly have enough money to get toilet paper in the Johns in the forests. So we probably could be backing off a bit on a lot of that because you start looking at the statistics, we're ineffective anyway. We could get much more wildland firefighting support for structural firefighters and make sure that we've got the safety thing down, and the rest of it is going to happen no matter what anyway. This is going to take a revolution in thinking about fire, and I think on our chromosome number 6, position 13, it probably says, hate fire. We're programmed to hate fire. And then we also feel waste. We feel a sense of waste if we don't go in, you know, and harvest and that kind of thing. And we'll even do helicopter logging at a loss. And I'm going, this just doesn't make sense to me. And I think it's in our heart of hearts we feel there's a waste. But if we knew the ecological story, we wouldn't feel the waste. We'd feel we need to celebrate the newness that comes from the death. So I still think ecology is missing, and every undergraduate should be required to have ecology with Eric Green. If he talks about fire. Yeah, no. Sure.
Yeah, it seems to me that as citizens, what we ought to do is to take some and leave some of our congressmen.
Right. Harvest some and leave some. I think what we all have going for us is we all want the same thing. It's going to be really fun. I hope I get someday a conversation with Daines, and you know, just because we all want the same thing. Everybody loves nature, and there ought to be a way to do a win-win. And I keep struggling with this, and my thought is it's mostly probably with zoning. We have places where we spend most of our effort on timber near the wildland-urban interface, and less as you get farther and farther away. And then let's at least do most of it here before we go out there, and leave that stuff alone. Don't worry so much. It's okay. It's not out of whack. Except if you're around Flagstaff, there are issues, and we probably need to be out there fixing these problems that we created at the turn of the century. But for most forests, yeah, probably not. Yeah.
Don't you think though that the attitudes are beginning to change?
Yeah. Well, I don't know. I hope so.
I mean, it seems like, maybe it's just because we're in Missoula, but it
Mhm.
seems like we have more, maybe it's.
I'm waiting. I'm waiting. I keep saying, if there's a city in the United States of America that's going to have a parade when the next severe fire hits, it's Missoula. And because we've hit, between my wife and I, we've hit every school kid in the city. Over 4,500 kids were bused up to Blue Mountain Fire, Black Mountain, and so, we're waiting. We're waiting. This could be a good year. And so, I'd love the rattlesnake to go. I don't want to walk that far, and so, just out my backyard, that'd be so great. Oh man, a new study area. As long as the houses aren't gone and the dogs are okay and stuff. Yeah.
Any more questions? If not, let's just give a round of applause.
All right, thanks.